when we're doing a rotation in a coordinate plane, we always have to worry about what the angle of rotation is going to be. It's 90 degrees. And when it says about the origin, this is going to be the point of rotation. And for all of these, the origin is the point of rotation, which is right here. Now, yesterday we talked about, alright, well, we could draw circles around these and then figure out where the 180 degrees would be by drawing the lines. But when we did a double reflection, which I think is the easier part because you don't have to draw the circles, you don't have to do a lot of measuring. When we do a double reflection, how does that relate to the actual angle of rotation? How much of the angle of rotation has to be between the two lines that we're going to rotate or reflect through? What did we have to do to, let's say, the 180? We had to multiply it by something. By a half. So we get 90 degrees. So now what I have to do is I have to take every point and rotate it 90 degrees, which means I have to put this through these two lines. And that's going to be 90 degrees. Well, the nice thing is, if I take let's take P, and since we're going to do a double rotation, we'll go through the x-axis and then we'll go through the y-axis first. So how far is P away from the x-axis? 1, 2, 3, 4. So I go 1, 2, 3, 4. Get P prime. Now how far is P away from the y-axis? 1. So I'll get P double prime right there. Now for K, if I rotate it through the x-axis, where's it going to end up? How far away from the x-axis is K? Well, the x-axis is this one right here. 0. It's right on it. So if I rotate it, if you're on the axis of reflection like this, it stays right there. So K prime is right here. So that's my first reflection. The second one is going to go through Y. How far away from Y am I? 3 to the right, so I'm going to go 3 to the left. 1, 2, 3. There's K double prime. Now for F, I get 1, 2, 3, 4. 1, 2, 3, 4 here. So how many to the right? 1, 2, 3, 4. So that would be F prime. Now, how many above am I? Not everybody at once. 2. So I go down to, there's K double prime, and now there's N. I can rotate it through here and then through here. There's 2 below, so I go 2 above, so there's N prime. 1 here, 1 here, there's N double prime. Now, which one are we concerned with actually having? N prime or N double prime? Okay, N double prime. So what we'll do is we'll take some type of straight edge and connect P to K, P double prime to K double prime. P goes to F double prime. Well, that's F double prime right there. P is going to end up right there. N double prime is right over here. Alright, so that's what we got with our shape. So we rotated that. Now, the nice thing about rotating 180 degrees is it doesn't matter which two lines you go through as long as you go through two of them, because you're always going to end up on the other side. There's P double prime. There's F double prime ended up way over here. K was over here, K ended up over there, N was up there. No, N was over here, N ended up over here. So you can kind of see how everything kind of rotates through. By doing the double reflection, it's going to be a whole lot easier for you. Now, the answers are all here. If you just do a Google search for Google software and look for rotations, their answers are there. I'll show you the answers in a second. I want to show you how to do number 4. Because it's going to be, number 4 is counterclockwise. So which direction are we going? Left or right? Counterclockwise means we're going this direction. Say that again? Okay. I was looking at number 3. Alright, we're going that way. Now, we want to go 90 degrees clockwise. So we're going to end up somewhere over here, aren't we? If we're going to rotate it, it's going to rotate kind of like that, right? So, what did we say yesterday about 90 degrees? What line do we need to use? Because what we need to do is we need to create an angle with 45 degrees. So how can I, since the coordinate plane actually hardwires in 45 degrees? So how are we going to come up with a 45-degree angle? Y equals X, absolutely. Y equals X, because this cuts a quadrant in half. So Y equals X is really nice because we're just going to get points like this. -1, -1, -1, just like that. And now, here's 45 degrees, there's 45 degrees, there's 45 degrees, there's 45 degrees. Now, if we're going counterclockwise, which direction should we be going? We should be going in this direction, right? So which line do I want to go through first? Do I want to go through this one, this one, this one, or this one? 1, 2, 3, or 4? Go through 3 first. Because we're trying to get this to go through here. So I'm going to go through this one first, and then this one second. And by going through 45 degrees, I should get a 90-degree rotation. So I'm going to go through this one first. U is how many spaces away from the first line? 2. So I go 2 to the left, and it just happens to be here. That's U prime. When I reflect over a line and I'm on the line, do I actually move anywhere? No. So U double prime is going to be right there. Now Y, I want to go through this line first. So Y is going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's Y prime. And now I have to go through this line right here, which could be a pain. That's 1 and 1 of those. So it should be over here, shouldn't it? Sure. Alright, so I need to make some type of perpendicular here. So it's 1 less than 1. So if I go to 2, there's 2 less than 1. And it looks pretty perpendicular because I'm straight on there. Okay, there's Y double prime. And U goes to Y, so now B here, I'm going to go through the Y-axis first. How many places is it away from there? 3, 4, 5. Then 1, 2, 3, 4, 5. Five and 1, so 1, 2, 3, 4, 5, and 1. So there's B double prime. Y doesn't connect to B. Y and U connects. I need U now. U is what, 2 over? Oh, we did U already. B goes to U. Now K would be up here. There's K prime. Then I have to go through this one. 1, 2, 3, 4, 5. 1, 2, 5. 1, 2, 3, 4, 5. There's K. Double prime. Alright. So, does that look like it got rotated? Just 90 degrees. Basically went 90 degrees is going to be halfway there. Is that what it looked like? Now, it takes some practice. If you haven't finished these, I want you to finish these. Spend the rest of the time working on these. If you haven't finished it, and by the looks at it, if you have finished it, you're good to go. Tomorrow we're going to wrap up transformations, and then we're going to start reviewing for our midterm. I'm going to let you guys catch up on some stuff right now. I know it's a pretty tough task to get back to school for the first week, so I'll give you guys a couple days to kind of get your bearings straight, and then after that we'll be good to go. But at least this gives you a couple ideas on how to get these done. Does it get a little bit confusing with the double rotations? Yeah. Do you want to see how to do this with just drawing the circles?
Is it necessary?
It's not 100% necessary. However, it's another tool to do it. I'll show you. What the heck? We'll take number 3. It's good to have this because it'll be on the website with different explanations. Since we're going above the origin, about the origin here, not above the origin. Hold on 1 second here. Alright. So all you do is whoops. Some people might find this one a bit easier. I'll use this. This is a whole lot easier to deal with. Alright, so I'll get my pencil. You put your center here. Alright, here's N. That's the best for N that I see. Alright, now we have to work with R. And that one didn't really work with R. So I got to go back to this contraption. Draw the circle around R. This is the old school way of doing a reflection without doing a double, or a rotation without doing a double reflection. And in this case, what you'll end up doing is you'll draw lines from the center to the different shapes like that. And now we want 90 degrees counterclockwise, so we want to go this way. We need a protractor. Well, we don't really need a protractor because we have one. And since I want to go 90 degrees, I want to go in this direction. So I want to set up this beast right here. And there's 90 degrees for that one. And that's the outer one, so that's going to be N prime or N double prime. I want to set this guy up. So I make sure that's at 0 or at 180. Put it onto that line. And there's 90, so there's another one, which just so happens to be really, really close to it. And thankfully this one's going to be a whole lot easier to deal with. I think the protractor might be a little bit easier to deal with because this thing is a pain, but it ends up working. There's your 90 degrees. Now B is on the second ring, so there's B prime. K, or whatever that one is, I think that's, I can't really tell what that is. X is on the inner ring, so X is right here. And now you just connect them. I'll connect them with green. And so this was able to take this guy right here and rotate it 90 degrees to that guy right there. Highlighters are great with this because once you get that, you see how messy it gets? It's going to get messy. It's okay if it gets messy. That's part of math. Math isn't the nicest thing on the planet. it gets messy. But highlighters help you kind of isolate everything that goes on from there. If I see this, I know you guys did it right because you did your circles. It's 90 degrees. It's going in the right direction. The shapes, I honestly, I'll do an eyeball test. The shapes, do they look the same? Does that guy look like that guy? Yeah. If this guy and this guy, you can tell whether or not you just totally messed it up. Because if this guy does not resemble this guy in the least, then you know you're in hot water, as so to say. But it looks good. It looks like you did it right, and I would give you 100% credit on that, because that looks, and since I'm a professional, I'll put that in quotes. I'm not a professional mathematician, but I'm a professional math instructor. That looks like you did it right. And also, whenever you're doing anything in a graph by hand, there's always a little bit of a fudge factor with it. It's just because we're human. If you want it perfect, use a calculator, use a computer. If you want it the best you can get, then you put your best effort into it and make it look as best as you can. That's just how it rolls. So, if you're not done with that one, finish it up. If you are done with that one,